Okay, quick announcement. For last Friday, I did some in-lab demo just about the cross syntax and how you can use comparator and sorter, which might be useful for your lab 1. If you're not too sure how to get access to it, just go to lectures page, and then you will see the link over here. Okay, and also the source code is also made available to you. You can feel free to reuse it. That's not a problem. And the second thing to mention, it would be very critical for you to know how to use breakpoints and debugger. It's quite a language independence technique you want to pick up for this course, hopefully, if you haven't. I do have some tutorial video to help you in case you haven't watched that. So if you go to the lectures page, I'll just show you how you can find it. Go to DDC and TDD, okay? Go to the tutorial. You will see number 5 is about how to use breakpoints and debugger. Try to see if you can follow that. If you're getting trouble, drop by my office hour. We'll make an appointment. I'll help you. And debugger and breakpoint will be your friend during the lab test or the project or labs, right? Because TA and myself may not be necessarily around you always. You want to rely on yourself more. Okay, so last time we basically started with the lecture about how to write complete postcondition. We're still doing a little bit of preparation work before we can show you how to write complete postcondition. Let's just continue with the preparation. We need a little bit more background in order for you to write complete postcondition. Okay, we talk about basically the 3 kinds of copies. We're going to see different examples for them just in a moment. But what I mentioned last time was just about how you can do conceptually. Okay, let me just review very quickly. Okay, if you want to do reference copy in IFO, you will simply say colon equal. It is similar to equals in Java. However, in Java, when you say equals to compare, it's simply just equal in IFO. So I would say forget about Java for now. Okay, otherwise you might just get confused. Okay, if you want to do reference copy over here, it's very easy. C1 is now just going to point to C2. Very cheap operation. However, as we'll find out today, to really have your postcondition do their duties, to be as complete as possible as the obligation on the supplier, you may not want to use reference copy, okay, in many cases. But we're going to find out exactly under what circumstances you might use reference copy. I would say not very often. Okay. The second kind of copy is called shallow copy. Okay, shallow copy does a little bit more. Okay, so now still C1 is still going to point to a new object over here. We call it a twin. Okay, think about this is what a runtime would do for you. Okay, you don't have to implement the twin yourself. Okay, so that's what you're going to call, and then we're going to create a shallow copy of C2 before we can assign that shallow copy into C1. How do we create a shallow copy? First of all, you create the objects, the blue one, brand new objects. And then for every attribute of this particular twin, we're going to do reference copy, okay, for every attribute. So at the object level, you're going to create a new object. But for every attribute onwards, you only do reference copy. Specifically, how do we assign this A? We will say whatever this twin copy, I'll say twin copy, okay? You can think about this is something that's hidden from you. You don't necessarily see that, but twin copy is some objects. Dot A. How can this be assigned? So rather than creating a brand new cloud, well, when I say cloud, which means it can be arbitrarily complicated. It can be as easy as an integer, or it can be as hard as maybe a million node binary tree. Depends. Okay. So now we say twin copy of A will just be assigned to C2.A. conceptually, but we're going to see a concrete example. In this case, it will simply just point to this particular C2.A, and then C1 is now going to point to this particular twin copy. Okay, that's about shallow copy. Okay, what's really important to notice is when you do shallow copy after this particular assignment, you can do several checks to help you. If I say C1, if I say C2 equals C2.twin, right? This is comparing the addresses. Apparently, that would be false. Okay, cross means false. Maybe let me be more clear. So that would be false. On the other hand, if you try to say C2.A equals C2.twin.A, we're just comparing their references, right? You can see they are pointing to the same objects over here, so that should be true. That's about shallow copy, right? Shallow copy might be a little bit harder to understand. You want to do something more than reference copy, but not too much. Okay, you don't really go extreme. Okay, final thing we're going to see before we see some new example is a deep twin. That's going to be a deep copy. Again, you just simply call deep twin. It's defined in IFO. They will do it for you. You don't have to do it by yourself. Okay. So for deep twin, again, we're going to create a new object of type C, first of all. So this first step will just be the same as shallow copy, just the same. However, we're going to go a little bit further to say now, how do we actually do C2.A? Okay. Again, let me say deep twin copy. Okay. Again, this variable is hidden. You don't necessarily see that. Okay. How do we know deep twin copy dot A? Now it's going to be assigned rather than just using reference copy. We're going to do deep twin recursively. So we're going to say C2.A dot deep twin conceptually. So what's going to happen is you're going to basically create an independent object over here. And then you can think about, structurally speaking, this object here is the same as this. They have the same structure. However, they are different objects. They're completely independent. There's no aliasing. Okay. So now if you try to do that, for example, if you say C2 equals C2 dot, I'll just say DT for deep twin. So that will be apparently false because you're creating new objects, right? Similarly, if you say C2.A equals C2.deepTwin.A, right? If you do that in the previous case for shallow copy, right, we'll see true. But now for the deep twin, it will just be false, right? Because the deep copy you're creating is completely independent from the source. Okay, that's conceptually how the three copies works. Very briefly. Any questions about the three kinds of copy? You have to be very clear about how to distinguish between those, because when you write a complete post condition, you have to be correct, but at the same time you want to be as efficient as possible. Maybe sometimes it would be sufficient just to use shallow copy, in which case using deep copy will be overkill. But sometimes you really have to use deep copy. Okay, question?
So this is just an IFO feature. This isn't like, you're not just showing us examples, like all of the classes in IFO have these methods?
Oh, actually, a good question. Well, Jordan's question was, is deep twin only available to certain classes? The answer is no. Okay. Basically, you can do deep twin. You can think about it's like a predefined method or feature in the object class, right? Or what? In IFO, of course, the top class, rather than calling objects, called any. You can think about the twin and also deep twin. They are available over here. So that means any class, for example, person or bank account, whatever class you actually inherit that from, you definitely get twin and deep twin available to yourself. And you do not try to override or redefine the twin or deep twin. It's fixed. Okay? It's correct and fixed. You just use them. Okay, that's a good question. That's good. Okay, any more questions about just conceptually? Yeah, go ahead.
I don't understand the DT underscore copy.
Oh, yes. So you can think about this. When you try to do this particular assignment, let me put it aside. When you try to do C1 is assigned to C2.deepTwin. Let's say if this is what you intend to achieve, right? In order to do these particular assignments, I need to, first of all, evaluate the right-hand side. Whatever the right-hand side might be, store its address into C1. So now under the hood, you don't really have to do it by yourself. The runtime is going to, first of all, in order to create C2.deepTwin, I'm just name that, maybe DT copy, right? Doesn't maybe call different name. Yeah. Okay. Once you create this object here, and then you're going to let C1 is now going to point to this particular object. Yeah, maybe I forgot to do the arrow. Maybe that's why you're confused. Okay. We're going to see more examples. We're going to see, and then you can keep asking me questions, right? It's really important to clarify that, okay? Okay, so first of all, let me go over one diagram together with you. So this diagram, do I have the page number? Okay, I don't. So this diagram comes from OOSC2, the textbook. If you haven't got a chance to read it, at least try to see if you can understand this picture here, right? That quite nicely illustrate the difference between the three copies. Okay, let me go over with you. Okay, first of all, I would suggest try to only look at only this area, okay, for now. Oh, let me just make it a little bit thinner. To begin with, only look at the green area for now, to begin with. Only look at the area, okay? So now the initial setup is such that you can see we have A, which is some variable. A is pointing to this particular object over here. This particular object. And that particular object has 3 different attributes, right? So you can see over here, they got name, they got landlord, they got loved one, for example, 3 attributes, right? And then you can see in the case of name, it's this particular name. In the case of landlord, it's simply pointing to themselves, just landlord of themselves. And then for the loved one, it's simply pointing to another object over here. It's just another person objects, okay? Okay, and then you can see for this particular object over here, that's the name. What about the landlord? The landlord somehow is pointing to this particular object over here. And the loved one is simply pointing to this particular objects. Okay, just like a setup for the objects. Okay, basically we're talking about a particular object with 3 attributes. And one of them is string, the other 2 are simply pointing to other persons. Okay? Okay, any question about the green one? Just initial setup. We're okay, right? Okay. So now we're going to consider 3 cases of copy. Okay? First of all, let's consider reference copy. That's the easiest one. Okay? If you think about, for example, B is assigned to A, so that means we're creating a new variable called B. And now, do we have to create any new objects? No, just reference copy. So that means the only thing we do is to simply say B is now pointing to this particular object over here. Just copy the address. That's reference copy. Okay? Good. Diagram is on your textbook, so you don't need to copy that, but just for your information. What about shallow copy over here? If you look at the shallow copy here, let's say C is assigned to A.twin. Okay? Remember the first step for the shallow copy is create an object first, which means we're just going to create another object of type person, for example, with the 3 attributes. Okay? And then we are now going to actually make sure every attribute is not assigned their reference copy, right? This is called the first level copy. Only you try to create a new object over here. After that, every attribute should be a reference assignment. Okay? So this diagram in your textbook is a little bit misleading, I can tell you, a little bit. Okay? In the sense that string is also a reference type. Agree? So now, if you think about original diagram, if I simply put this guy here, let me just write it a bit more properly. You can think about the name is now pointing to whatever name it is. I'll just put Alan. It doesn't matter. Okay? So now when I do shallow copy, right? So now for this particular name field, rather than creating a new string, I want to make sure its name is now going to point to the same string object called Alan. Agree? And then, now, what about landlord? That's my question. Do we have to create a new landlord, like a new object? We don't have to, right? You can think about, in this case, this is called B, sorry. So this is called C, right? You can think about C.landlord. It's as if C.landlord is assigned to A.landlord. Just do a reference copy at the first level. It's as if. So now what's A.landlord? A is now this object here. Landlord is now pointing to this particular object. That is why C.landlord over here is also going to point to the same object. You can see the red. I want to make it more obvious to you. Okay? This is pointing to this object here, just as this is pointing to that same object, landlord. So only reference copy at the first level. Okay, similarly, what about loved one? Okay, in order for me to figure out the loved one for this particular twin copy, right? What's the loved one for the previous one? Loved one is now pointing to Susanna over here, right? So that means the loved one here is also pointing to Susanna. Let me make it obvious to you. Okay, so the green, they're pointing to the same. Okay, same objects. Only create an object at the 0 level. Well, just create an object first, and then attribute at the first level and onwards will just be reference copy. Question? You mean reference copy versus shallow copy?
Yeah, because they're both.
Uh-huh.
The shallow copy would take a little bit more.
Yeah, That's exactly the point. So shallow copy definitely takes a little bit, one step further to create a brand new object. Although, starting from that level, everything's aliased. You will see. Okay, just hold that question. It's good. You have some doubts. Question?
So I think it's kind of similar to what he asked, but is there a big advantage to shallow over just the reference copy?
Okay, that's a very cool question. The question was, so what would be really the advantage of shallow copy over reference copy? First of all, shallow copy is more expensive for sure, okay? And reference copy is cheaper. However, when you talk about for the purpose of writing postcondition, we're going to think about if I actually want to compare, let me just draw some conceptual picture for you, okay? We definitely covered that, don't worry, but I just want to, since you have some doubts. Imagine this. For your particular feature f, okay, so we have some, let's say we don't have any precondition. You have some implementation here, and there you have ensure, okay? And there you have end. So now, in order for me to actually write some postcondition, I need to refer to the pre-states, right? I might say old 8. Let's say A is an attributes. That's a reference type. Versus, if I might say old A dot twin. That's another possibility. Or I might say old A dot deep twin. Writing each one of them makes a huge difference as to what it really means. Okay? So the reason that we want to just cover what reference copy really means versus twin versus deep twin is because once you put them into the context of postcondition, they're going to make a huge difference. Okay? As to exactly what the difference is, bear with me. Examples are coming. Okay? Basically, you take this one, or this one, they might trigger different kinds of copy in the pre-states. Of course, there will be cases where deep twin is unavoidable if the kind of changes you're trying to do actually modify deep into the level for the object structure. But we'll see. Okay, we'll see exactly like that in just a moment. Okay. All right. Okay. Finally, if we want to look at the deep twin, okay, let's say B is now assigned to A dot deep twin. Apparently now we're going to create new objects recursively. So what's important for you to see is this. If once we're done, you can see that the object structure over here, the pink one, is completely independent from the green one. Completely independent. There's really no arrow pointing from the pink to the green. Right? So that's deep copy. Okay? When you write a postcondition, you will, well, our conclusion maybe at the end of Wednesday will be, when you write a postcondition, it doesn't hurt to always write deep twin. However, it might be overkill in some cases. And what do we like to ask you about in the exam? We want to say, consider this particular case for postcondition, is it really necessary to write deep twin? And you have to justify. Right? That's kind of the stuff we want to do in the lecture to really show you the exact scenario that you're going to deal with. Okay. Any question about the diagram here? Yes?
Wait, so that landlord thing is confusing me.
Yes.
Because it's pointing to the original object in the earlier.
You mean the shallow copy or the deep copy?
Yeah, so when we were doing the shallow copy,
yeah.
C's landlord was A because A was pointing to itself.
Mm-hmm. Correct.
But when it happens to be that, like, wouldn't it just
you think it
create a copy of A and then create
Oh,
a copy of A?
yeah.
And it would,
Basically, okay. Think about what the implementation of deep twin would do. The deep twin is going to find out when I first create a when I first create a duplicate of this particular object, I'll realize it does have a self loop.
yeah.
That is why when I create this particular object, I should have a self loop as well.
Okay, so
You will figure out. Yeah, yeah. It's quite a challenging programming exercise to do if you want to do it, right? Basically, when we said back in
it would have to do that for like every attribute that matches the same class, then, right?
Exactly.
You would have to check if it's
yes, it has to be done recursively.
That's interesting.
Yeah. So the structure, if you look at the structure for the objects between the green and the pink, they are exactly the same, even though they're different objects. Okay, that's the key. Yes.
Branching off the point,
Okay, let's see this. Okay. So you want to write some Boolean expression if I'm getting, okay. What would you like to write?
C dot landlord equals A.
Sure. C dot landlord, for example.
So C dot landlord equals C.
Okay, sure. First of all, C dot landlord equals A. Let's do that first. Okay. First of all, C is over here. C dot landlord is now basically pointing to exactly just this A, right? This object here. Okay, so it is true. That's fine. What's another one?
And then C dot landlord equals C.
C dot landlord equals C. So that one there, C dot landlord is equal to C. Yeah, that's also true, right?
Wouldn't it be false though?
I'm so sorry. I'm so sorry. So C, okay, C is basically this shallow copy over here. So we talk about this is C, right? C dot landlord, if you follow the link, is now going to be just A. Exactly, right? So now if you say that's equal to C, that'll be false. Yes, exactly. Yes, yeah. So what would be the best way for you to figure out the assertions over here for Boolean? Well, draw the diagrams. That's the best way. Okay. Okay, it's in the textbook, so I thought I should mention that quickly, just in case you run into trouble understanding that. Okay, so now what I would like to do, I'll give you a little bit better to understand example before we write the actual post condition. Okay, so we want to get array into play. Okay, you want to talk about data structure, but array would be a nice one to illustrate the concept. Okay, so now we're going to talk about collection of objects. Basically, eventually in your post condition, you have to worry about how is the supplier supposed to change the collection of objects. Okay, that's basically what we want to do. Okay, in object-oriented programming, we want to make sure every time you refer to a class, that means you want to store its address. Okay, it's a very important concept to realize, right, for OOP. And then let's now consider simple cases. Okay. Let's say we got two arrays, imp and old imp. Somehow they're related, somehow. I'll explain how exactly in just a moment. We got two arrays of strings, and then we have, let's say, first of all, we create an empty array for the imp. And then we try to force in Alan, Mark, and Tom in sequence, right? We talk about the force in the Friday's lab demo. Okay? You can review that to see how you can do force. This is what we want to do. You can think about for all the versions we're going to consider in the subsequent pages. Okay, we're going to start with creating these arrays over here, just imp to begin with 3 elements, and then we want to do some changes to imp. There's some change we want to do to it. Before we do the change to it, we want to say we want to copy somehow the imp into old imp. Okay, before you do the change, and then you go ahead and do the change. After the change, we want to somehow compare the imp and the old imp. That's pretty much how what a good post condition should do, to compare the old version and the current version of the imp. A very good post condition should be that if any changes you try to make to imp, it should be visible between old imp and imp. Okay, a little bit abstract, but we'll see example. Okay. So what we really want to decide in many versions from now will be to see whether when you compare old imp and also imp, can you see the change? Question.
So how does the keyword old come into play with this?
The old keyword. Oh, don't worry about old keyword. So you can think about the old imp over here is just a variable name. We don't use old keyword just yet. We'll get there. We're still trying to prepare you for the background. Not yet. We're getting there. Okay. Think about the old imp is more like the old version of the imp before we try to do any changes. Okay, so now try to look at that. So this is the diagram here we're going to see for every version. Imp is now pointing to an array over here with, remember, indices start with 1. Okay, so we're pointing to Alan, Mark, and Tom in different indices. Now, before we try to do anything, any change to imp, we want to somehow to say old imp should be a copy of imp. Well, but what kind of copy should it be? Maybe it's a reference copy, maybe it's a shallow copy, or it's a deep copy. We're going to see all the cases. Okay, that's basically the roadmap. Okay, we're going to see many versions. Just make sure you don't get lost. Okay, version number 1. Let me just go through the code a little bit together with you. Okay, so let's say before we do the change, we simply say old imp is assigned to imp. So we are basically doing a reference copy, right, before we do the change. And then what we will do is, so now let's say result would be OImp equals imp. Should that be true or false? True, right? Okay, it's a quick test. It's true. Okay? And then let's say this. This is the change I would like to make. I'm saying do the following change to imp. In line number 2, assign the second element in imp to a new string object called Jim. So now, after this, if I run the following check, well, we learned about across, right, on Fridays, so it's good that we introduced that already. But let's try to read it. You're saying across from lower index 1 until the largest index for imp. We want to make sure every element in the position-wise correspondence, right? In the corresponding position, imp at position j is the same as OImp at position j. Basically, what this is trying to do, I got imp, I got OImp. After certain changes already for imp, I want to compare if they are still the same. Think about that's what a post condition should do. A good post condition should really tell you they're different. But is this going to tell you they are the same or different? The same. So that means in this kind of scenario, reference copy is not a good way to get the post condition you want. Okay? Let me just illustrate this quickly, just in case you haven't got it. Okay? So now thinking this way. After this guy here, line number 1, we simply say OImp is now simply just going to point to imp, right? It's a reference copy, okay? And then in line number 3 over here, we're going to say imp2 is assigned to Jim, okay? So imp at position 2 is now assigned to Jim. I'll just say Jim. It's a new string object, okay? That's the setup we have. So now when we run this particular cross loop, or cross all, how many iterations, first of all? 3 iterations, agree? Because the size of the array is 3. Okay, let's just write it out just for the first time. J is going to be 1, and also 2, and then 3. For the first iteration, you're going to run this, and then imp at position 1, tell the OImp at position 1, true or false? True, because they simply just refer to the same objects. Okay, and then second iteration, and notice that this is the change that we're supposed to see, because previously we said imp2 is assigned to Jim. And now would this be true or false? I heard true, I heard false. We're not too sure. Why don't we try? Why don't we try? If you try the following, okay, here, imp position 2. Imp is now pointing to this object, position 2 is now pointing to this object here, agree? And then OImp2. OImp is pointing to here, position 2 is also pointing to the same object, so they are the same. All right, this is not the trickiest case yet, but you gotta be careful, okay? So that means this one in here is also going to be true. So true, and then if I change it to position 3, you can see that's also true. So that means if somehow your post condition is only trying to make a reference copy of the pre-state value, it turns out it may not be very useful because it's simply just aliased to the object you're trying to change. Of course, you cannot see anything when you're trying to compare the 2 versions. Guys, any questions about this? Questions? Okay, so now, line number 3 here. Okay, you're trying to do an assignment first of all, right? The left-hand side is saying you're not trying to reassign imp. Rather, you're trying to reassign the second position of imp. So where's the second position? You can see imp is now pointing to this particular object over here. If you go to the second position, you want to redirect that arrow. So now, rather than pointing to this original mark, it's now going to point to the new object Jim. It is what it is doing. Okay. But you cannot tell, right? Because you will hope. Basically, thinking this way. what you have to see is this. Okay, you want to consider the following lines. First of all, we know that oimp is now pointing to just the same object as imp, first of all, right? You agree with that? Okay, so now, if you see that, if I say imp at position 2 is simply equal to old imp at position 2, I argue that it will always just be true. Because imp and old imp, they are simply just pointing to the same objects. So it doesn't matter how you change in this way. It will just be the same objects. Okay, aliasing, basically. Okay. Yeah, think about it. Think about it. I got many versions for you to think about. Okay, that's version number 1. It's a warm-up. Okay, you will see the complete diagram here on the slides, right? But I thought illustrating it might help. Let's now talk about shallow copy. Okay. Let's say we try to do a shallow copy instead for the old imp, and then we'll try to do the same kind of change we did previously. Are we able to see the change right now? That's the question. Okay, let's see. Okay, again, let's check very quickly. Line number 1, I simply say old imp is simply assigned to imp the twin. Okay, I'll draw the diagram in just a moment, but try to see if you can picture that in your mind. Now, quick check. If I say old imp equals imp, true or false? False, right? Well, shallow copy, right? It's going to be a different objects. Okay, it's going to be false. Good. And then let's now do the same kind of change. Now I'm trying to reassign the second elements of imp into Jin. Now I want to know, after this change, if I try to run the same across loop as before, am I going to get true, which is not good because that means I cannot see the change, or am I going to get false? Oh, just for this particular setup. Hey, that's good. Just for this particular setup. True or false, guys? I heard true. Okay. I heard false. Okay, true and false, right? There's no democracy here, right? So scientific, it's only scientific truth, right? Let's see. The answer, well, we'll see. We'll see the answer. Maybe once, as soon as I start drawing, you'll realize it might be right or wrong. Let's say Jin is not there already, let's say. Okay, let's try the following. Let's say over here, if I try line number 1, okay, how do I visualize this? So basically, I'm going to draw old imp. Okay, what I need is a new array objects over here. So old imp is now going to point to an array of string. I'll say array of string with 3 elements. Okay, that's basically the object to create. Now, starting from the first level, do I have to create any new string objects? I don't have to, right? So that means now, old imp at position 1 should be pointing to the same position as imp at position 1. Agree? So now this one should point to this object over here. Agree? And then old imp at position 2 should point to imp at position 2. Old imp at position 3 should now point to imp at position 3. That's the shallow copy. I'll pause a little bit just in case you got questions. Are we okay with the shallow copy? Question first.
If we do change something in either.
Oh no, not yet. Just let's focus on this diagram first. Yeah. Yeah. Are we okay with the diagram here? Okay, good. Okay. So now let's say this. Let's say we focus on this particular change over here. Let's say what we want to do is imp at position 2 is reassigned to Jin. Imp, which is different objects, we want to say at position 2 is now reassigned over here to Jin. Okay? The way we reassign is just the same as before. But now it's just that the old imp has been created differently. Okay? So now a question for you. If I try to run this particular across loop, now would you change your mind? You're going to get true or false? I heard false. Okay, if you you change your mind, that's a good sign. Okay, if you don't think you will change your mind, that's okay, right? It's good to struggle a little bit. Okay, let's see this. Again, we will agree we're going to run 3 iterations, right? Okay, so now let's try that. For the very first iteration, we're going to see j will just be 1. 1. Let me just make it clearer for you. Imp at position 1, tell the old imp at position 1. Should that be true or false? True? Agree? Okay, let's see why. Imp at position 1 is now pointing to this particular string, and now old imp at position 1 is, because the shallow copy is pointing to the same string. Okay, so that's why it should be true. Question, yes?
The tilde invokes is equal, right?
Yeah, tilde invokes is equal. Yes, correct. Yeah, but I think it doesn't really matter because
It doesn't matter in this case because
yeah.
it's self-directed.
I think when you try to study this example here, it's really important to see how the arrow goes, so you can see what's going on here. Okay, let's do the second loop. Now, if I try imp at position 2, tilde old imp at position 2. So now, do you think it's going to be true or false? False, right? Okay, I hope you see that, but let's make it obvious to you. So now, let's see this. Imp at position 2 is now pointing to Jim, versus old imp at position 2, right, is now pointing to this original mark. So they are different objects, agree? Okay. So that's why, in the case of shallow copy, it will be able to tell the difference between old and new version if you're doing this kind of change, which means you're reassigning the references at the first level. Okay, the follow-up question would be, is there a kind of change that cannot be told, cannot be determined by this kind of shallow copy? Is it possible?
If you're just overwriting the string, let's say, at the same spot.
Oh yeah, exactly. Which means you're trying to do something beyond the first level, basically. Go ahead.
So let's say these are integers, and I did like get 2 is the size of like 10 different ones. It would overwrite. It wouldn't make a new object, right?
For integer, okay, so let's say this. If you talk about integers, basically, for example, if you say rather than assigning to this, you assign to, for example, integer 4. Conceptually, you can think about, you simply replace that just by 4, just a value over there. Yeah, so everything is an object in iPhone, everything. However, for integer, Boolean, the so-called primitive types in Java sense, there's something called expanded, which we'll talk about. You can think about they're like primitive. So they simply occupy the space over there. There's no address for them. Yeah, but just an aside. They don't really call them primitive. They got something called expanded clauses, which means they don't really have an address associated with them. But we'll get there. Yeah, it wouldn't hurt to think of integer, Boolean as primitive. That's fine for now.
Okay.
Yeah, good question.
Is there a way to modify what the pointer points to instead of pointing somewhere else?
Oh yeah, exactly. So the question was, is it possible, let's say line number 3, rather than simply reassigning imp2, is it possible just to modify that particular object? Yes, that's exactly what's going to happen. We'll see. Yes, question?
So if it would be an array of integers rather than an array of strings, then like shallow copy would be...
Ah, that's very good. Okay. So you might go a little bit ahead of what, the pace, but that's good. Eventually, if you only got an array of integers, characters, or Boolean, like a primitive types, you don't really have to do you don't really have to do deep copy. Shallow copy will be okay, because they are not really like objects. They don't have recursive structure. Good. But we'll just talk a little bit more like a general case. Okay, let's talk about another one. Okay, we still got shallow copy. Okay, again, there's a complete diagram. You can look at that. Let's say we talk about the second kind of change you want to make on the shallow copy of the old imp. Okay, so now we still got old imp is assigned to imp.twin. That's still what we got. And of course, this will be false. Okay, we have done that already. Let's say this is what I want to do now. Am I creating a new object? No. I'm basically following the pointer and say, whatever imp2 is pointing to, just append some junk to the end. I'm not really creating any new objects. Okay? Let's say this. Given this, picture that in your mind, and then we'll draw an illustration in just a moment. If I try to run the same across loop, try to see if the imp and old imp are position-wise equivalent to each other, am I supposed to get true or false? I heard true. I heard true, I heard false. Okay.
You're going to get an error.
Why would I get an error?
Okay, we're still talking about shallow copies. So
Oh, it's a shallow copy, yeah. Actually, when you talk about error, you mean runtime error or compilation error?
No, so it's a shallow copy.
Oh, yeah, that's fine, that's fine. But when you say error, maybe either true or false, right? Okay. Okay, if you got your answer, hold it, and then let's see if we can find out the answer together, okay? So now, this is second level, well, basically beyond the first level. So let me draw the diagram again very quickly, okay? It's going to be very similar, okay? So what I will do is old imp. So after the twin, old imp is now simply going to point to a new array over here, and then position 1, pointing here, position 2, pointing to here, position 3, pointing to here. Okay, that's a shallow copy, right? So now, if you look at this line here, line number 3, imp at position 2. Imp at position 2 is over here, append star, 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 okay? Basically like this. Rather than it's being marked, I'll put it here, okay? It's just going to be mark. Star, star, star. The same string objects, but now its content has been modified, okay? This kind of change is actually more often if you do OOP, because you want to go deep into somewhere in your object structure and modify something, okay? But just one example. So now let's go back to the original question, right? You can see it's the same across loop we try to run for every version, just saying. If I want to run this particular loop, okay, let's do one by one. If I say imp, the first iteration, j is just going to be 1, right? Imp position 1, tell the old imp position 1. Okay, true or false? True. Okay, let's see why. Because over here, imp position 1 is now pointing to this particular string. Old imp position 1 is also pointing to this particular string, the same. Right? Good. So now, what's more worth looking at will be the second iteration. And I'm going to draw that. Imp at position 2, tell the old imp at position 2. And notice that in line number 3, this is exactly where I modify, where I made a change. So now a good post condition eventually should be able to allow me to tell the difference. But now, am I able to tell the difference? Okay, so you're saying, should that be true or false, first of all? True. Okay, let's see why. Because now you will see, because the shallow copy, so now imp at position 2 is now pointing to this particular string object, which is about mark star star star. Okay? And now if I go for old imp at position 2 is over here, it's also pointing to the same string, which is also pointing to mark star star star. So you can see if you're trying to make any change beyond the first level, shallow copy, it may not be good enough for you to see the change. Okay. So far we have seen 3 versions so far, right? 1 version for reference copy and 2 versions for shallow copy. So shallow copy can work if the kind of change you're trying to make is very, very shallow, or if the collection is simply a collection of primitive, basically. Question?
Back to the first example where you were assigning Jim to any of the
Sure.
next two.
This guy here?
If you were to enforce the index of 2, would that be, would you get the same result?
You were saying, oh, it's a good question here. Okay. Good question. And I would suggest I try to, okay, let me see how good I can do this. Pretty good. You were suggesting I should do the following. Rather than, let me just rewrite it, okay? Rather than this, I'm going to say imp at position 2 dot force, right? Let me write it down first, and then we'll talk about it. We say force, and then let's say Jim to the end of the array. Actually, I like the question. Jim, and then let's say imp dot count plus 1. Right? That's kind of the pattern we set the other day on the in-live demo. Okay? So guys, there's a new exercise for you. We'll solve it together with you. Okay? Let's say line number 3 is the kind of change I want to do over here. Am I still going to get true, or am I going to get false?
If you're already setting
Okay, thinking this way. Think about what this is trying to do. Think about if currently imp, let's say if this is imp, right? Currently the count will be 1, 2, and 3, right? If I want to force something to the end, I should force at index 4. Remember, indices start with 1. So that's why when I say imp.count plus 1, that'll be 4. So that means I'm forcing a new element at index 4.
then why are we saying imp at index 2? You say imp at index
Oh, what am I doing here? I'm sorry, I'm just confusing, right? What I meant to really write is,
and then wouldn't it be, so I think he was asking at index 2. Force at index 2.
oh, okay. Are you asking, okay. First of all, if you say imp 2 dot force, right? First of all, it wouldn't even compile.
There's another version of force where you can say value imp.force and then you say gym and then
Oh yeah, exactly. That's what I'm writing. Okay. First of all, would you agree this one doesn't make sense, right? Because imp2 is actually a string. You cannot force it to the end of the string. Okay, good.
I was going to say imp.value.
Okay, so I think this guy makes sense. Agree? Okay. Imp is the array, force to the end, and then with gym. Okay, good. That's the correct version. All right, question for you. If this is the code I give to you, question will be, if I run a cross loop from 5, 6, or 7, am I going to get true or false? I heard index out of bound. That's another possible answer. Okay, how about true, false, index out of bound, or others? Whatever, that's not the 3, right?
This compiles, right?
This compiles, I believe.
It's impossible to have index out of
Anyone? Why don't we try to draw the diagram and then we'll find out. Okay? Actually, I like the fact that you might think about there might be index out of bound, but possibly not in this case. Let's see why. Okay? After all, we are trying to do reference copy, agree? So now if I say old imp over here, old imp is now a reference copy of the imp. Okay. First of all, do you agree after line number 1, this is how it looks like? Agree? Okay. Now, if we try this, imp.force, and then what's imp.count currently is 3. 3 plus 1. So that means we want to expand it with index 4 over here. And then it should be pointing to, so this is basically imp at position 4. It's now pointing to gym. That's what's going to happen. Question? Oh, no. Okay, I see what you mean. There's a nice confusion, but let me point it out. Remember in the slides, what I said was, we started with, for all the versions, we started with over here. Think about, for all the version we're presenting, we always start with these 4 lines of code. We always set it up so that we got 3 names already there. Just, otherwise we don't have enough space for the slides. Good, no problem. Okay, so now let me go back here. Okay, let me get it straight. Is everybody okay with, first of all, the reference copy, right? And then when I do this force, it's now going to modify and then have gym over here. Good. Question?
Force modifies the array. It doesn't create a new array.
Oh yeah, because force is more like a feature call. So when you say imp.force, you're only modifying imp. You're not creating any new objects. Yeah. Let me continue, and then maybe you'll come up with your questions. So now, if we try again for this guy here, okay, this guy here, if you do the cross, are we going to get true or false? Maybe true, right? Let's see why. Okay. So now let's see this. First of all, if you say imp at position 1, and then tell the old imp at position 1, they are just, well, imp at position 1 is pointing to here. Old imp at position 1 is also pointing to just the same object. So that should be true. Okay? And now, now, for this particular cross, how many iterations are we going to run? 4. So this is already different from the previous example, right? 4 iterations. So I'm sure you can figure out for the first 3 iterations, the last iteration, let's think about it. Imp at position 4. Tell the old imp at position 4. So now, are we going to get index out of bound exception? Not really, right? Okay. So now, imp at position 4 is not just pointing to here, right? Old imp at position 4 is also pointing to the same position, right? They're pointing to the same string object, so also true. So overall, it's going to be true. It's a very good question. I like it. Okay, I want to make one remark. Okay, before you ask further. Okay, think about the way you're trying to basically modify the array just by growing the size of the array for the same objects is already beyond the first level. That's why the twin cannot actually tell what's there. Okay, can I just give you guys some exercise? Okay, think about it, and then I'm going to take more questions from you. So now I'm going to do the shallow copy version, give you one exercise. Okay, I'll try to see if I can do this properly. Okay, exercise for you. Okay, exercise. Let's say now I have the shallow copy over here, twin, as opposed to reference copy. Now over here, rather than having this, now I want to do exactly the change you were suggesting me do. Okay, I would say imp dot force, and then gym, let's say. And then I would say imp dot count plus 1. You don't need to tell me the answer, think about it. Imagine if this was the exam question, what we would expect you to do. First of all, tell me what the output is at runtime. Number 2, explain. Okay? Exercise. What's going to happen if I try to run this particular guy here? True, false, something else? I don't know. Okay, exercise. Okay, any question until now? Are we okay? Question. Yep, that's a good question. I would like to make it clear. Okay, let me just, since I can do copy and paste for infinite number of times, I will just do it. Let's see over here. So you want a shallow copy, right? Let's say. Okay. So now you're saying rather than having this guy here, you want to say imp at position 2. Oh, just force. Okay. I might see what you're saying. If you say force at position 2, and then gym. Oh, actually, let me get it right. Sorry, gym first. I want to force gym into the array, but at position 2. That's your question, right? Okay. Again, this can be another exercise, but I'll give you a little bit hints. Doing this is as if equivalent to if you say imp at position 2 is assigned to gym. That's my hint to you. When you say force, if the index you're trying to force into is valid, it's as if you try to assign to that particular index. If it is not valid, if that's just one off, you're inserting. It doesn't shift? No, it doesn't shift. Yeah, it's as if. Yeah, it's not like an insert. You just force into it. Yeah. Question? Yeah. Yeah, exactly. Yeah. So, I would say it might be worth for you to think about exactly what's going to happen. Again, I would suggest that's another exercise for you. And what I would like to see when you solve this exercise is by saying, what's going to be the consequence when I do this particular assignment diagrammatically? And then what's going to be the consequence if I do this line over here? and then try to illustrate how the result is gonna come out by you running the across loop exercise. Okay? Yeah, Alan. Say it again, sorry. You mean the array? I would say the size of the array should be kept as static, because if you grow the array, it's quite expensive. Even though IFO does allow you to force into the end of the array to grow exactly size 1. It's actually possible. But I would say efficiency is not our concern for this course. I did. No, I didn't do it. Okay. If you look at the question is really about initial size. You can see the way I did it was like this. You can see over here, when I first created the array, make it empty, you can think about the size is 0. And then when I say force, you're going to grow it to 1. You know, actually, you think about dynamically the size of the array. Well, think it this way. Immediately after this imp.make empty, if I say imp.count, it's going to be 0. And then after imp.force ln1, after doing that, imp.count will be 1. That's more like it does grow dynamically. Yeah, it's not quite the same as how you would do it in other programming language, but just the way it works.
So does the void safety catch if you're going to an index of array that
Does the void safety, or how about does the compiler tell if you actually give an index that might go out of the boundary? The answer is no. Okay. It will be a runtime error. Basically, you're asking the following question. Okay. Let me make it precise. Let's say if I have some expression like an A, let's say A is an array of something. And then you simply got some expression over here, right? It could be as easy as maybe simply just 2, let's say. Even that, you cannot really tell statically whether this will be a valid index or not. Because how do you know what's the size of the array at this point? Well, for those of you who took 2001, tracing the behavior of the program dynamically is an undecidable problem, which means there's no program which can solve this, but just an aside. Okay. Anyway, my point is, for whatever expression you might put over here, okay, invalid index is a runtime assertion error, not really a compile time error. Okay. Invalid index is a runtime error, not compile time. Yeah, you guys are more curious about those back in fall 2019, which is good. Any other questions about what we have seen so far? We need more example. Yes. If I understood correctly, you're basically asking about how to use a variable, right? In Java, let's say, well, Java and IFO, I think to that respect similar in the sense that if you talk about in a particular class, right? Class, maybe class something, okay? If I declare attribute A and B over here, and then I have some feature over here, okay? And then this is the body of the implementation here. Let's say I got attributes C and D. Somehow C and D are declared after F was declared. So the question is, can I use C and D inside the body of the implementation for F? The answer is yes. So in that respect, it's the same as Java. Okay, you can use that. On the other hand, when you talk about the implementation body for the feature, you cannot just declare local variables as you wish. You have to centralize them in a place. Right? So you have to say local over here, and then put all the variables you might need over here up front. And then in your body of implementation over here, you can now refer to either local variables for this particular feature, or you can refer to any attributes that are declared in the same class. Yeah, so if that answers your question.
What about a function or a feature? Is it the same thing?
The same. So it doesn't matter. So for example, if you declare, okay, just in case. So now let's say I also declare another function called g, something over here, and then with some body of implementation, g was declared later than f. Can I use g over here in f? Yes, I can also do it. Okay. Okay, question.
If let's say we declare a local variable, let's say local we declare A, how do you distinguish if you're using feature and if you're new? How do you distinguish between like
Okay, you can check it out for me. I believe, in Java, if you got, let's say, parameter name, the same as attribute name, you can use this. For example, this.a equals A. If I remember correct, I got to double check. It's been a while since I used this. But my first impression is this. If I have a class over here, if I have attribute A, for example, okay, and then if I got feature over here, if I say A, let's say A is of type integer, for example, and then I say input A is of type integer, I believe you will get a compilation error. I believe. But check it for me. I might be wrong. If I'm wrong, I'll correct that next time. But I don't quite remember. Yeah. Okay. Well, it's a bit off the track, but anyway, it's still relevant. Okay, so far we talked about, okay, let's talk about deep copy very quickly, shall we? Okay, have we talked about deep copy? You got questions? Yes, go ahead.
so Professor, when you create an array, right? What is the default size of it? Is it not 0?
Default size? Yeah, 0. So the way you create an array is by doing this. So when you say creates, for example, array A, make empty, right? It makes sense for make empty, right? So now over here, if you say A.count after this, it should be 0, default size. And for your information, by default, the lower and upper, what should they be? By default, lower is 1, upper is 0. Does it look strange to you? Yes? No? Yeah, exactly. That's exactly what. I tell you what would make sense. Just for your information. If you think about an array in general, if somehow this is A.lower and this is A.upper, of course, does allow some flexibility. A.lower can be any arbitrary number. A.lower, A.upper can be any arbitrary numbers. Okay, in general. So now, if I give you the value for A.lower, I give you the value for A.upper, what should be the size of the array? Okay, so you're saying, should it just be A.upper minus A.lower? It's more like a math. A.upper minus A.lower, is that what you're saying? Would that be right? I'll give you one example. What if A.lower is 1? A.upper is 10. I have 10 elements in my array. If I only do 10 minus 1, I only get 9, right? Okay, you should know that. Hack it, plus 1. So now, this is a general formula for given lower and upper indices. How do you figure out the size? So why is that relevant? So if you now see over here, so now upper minus lower, right? Upper minus lower plus 1. Applying this formula, you get exactly 0. And makes sense. Empty array, you got size 0. Oh, just to explain. Okay. Do you need to memorize the detail? Not really. Question?
Since we have the lower and upper bound
Yeah.
for when the array starts and ends, we have negative indices.
Yes, in theory, you can have negative indices for your IFO program if you can justify that.
Yeah.
That's okay. That's not a problem. Yes, but I would say in general, if we didn't tell you explicitly, it will start with 1. Okay, implicitly. Yes. All right. Good. Okay, let's talk about deep copy very quickly. Okay, and then we have to talk a little bit about new keywords, the old keywords. Okay, we got about 15 minutes. Okay. Okay, what about deep copy over here? So now, hopefully, now you can. I tell you what, shallow copy is the trickiest one to understand because you don't really go extreme. Once you go for extreme, things get easier. Okay. What about deep copy over here? Well, if I do old imp is assigned to imp.deepTwin, apparently, this is how it's going to look like. You know what? Can I cheat by just copy this guy here. Basically, it's just going to be an independent structure. Okay. If I do this one here, and then this rather than imp is going to be old imp, and this is old imp 1, and this is old imp 2, and this is old imp 3. So that's the consequence of running this particular one with a deep twin. Guys, is that clear? You're not happy, or you're not happy that I didn't draw it? It's okay, right? Okay. If you really want me to draw it, drop by my office hour. I'll draw it for you. Okay. Okay, so that's the deep copy, right? So now it should be quite obvious to you. Okay. Let me ask you two things at the same time to save time. Okay. Either we try to say imp2 is assigned to Jim, or we say imp2.append star star star. In both cases, are we going to get the same results for the across loop? That's my question. Would you think we're going to get the same result or different? Same result, which should be false. Very good. Okay, let me illustrate very quickly, just for those of you who are not too sure. Given that this one here, which is going to say imp2 is now going to be reassigned to just Jim. And now it's quite obvious because now when you run this particular across loop, you can see old imp at position 2 is pointing to this particular object, which is Mark. And imp is now pointing to Jim. Mark is not Jim. Right? That was easy. Okay? That's the first case. And then I want to just copy this guy here and then illustrate to you finally, okay, for this particular set of examples. Sorry. Now, if I do this guy here, okay, that's a deep copy, right? So after the deep copy over here, I have this. And then if I say imp2 .append, imp2 over here .append is now going to be the same objects, but now it's going to be mark star star star. So now if I try to run this particular across loop, apparently in the second iteration, old imp at position 2 is pointing to this particular object over here, and then imp at position 2 is now pointing to this particular object, mark star star star. They are not the same, right? So that means you're going to get false over here. So now the point is, for this kind of change beyond the first level, only deep copy can help you catch them. Shallow copy has its own limitation, but it's cheap. On the other hand, deep copy is expensive, but if that's really the way it requires you to do, you should do it. Okay, any question about the examples that we talked about so far? Okay, so far we haven't used the old keyword, just not there yet. We're getting there, very quick, very soon. Question? Yeah, in this case, it's going to return false. Specifically, in the second iteration, you're going to see old imp at position 2, right? It's this object here. It's simply just mark. On the other hand, imp at position 2 is now actually mark star star star, right? That's why they are different objects. Yeah, exactly. It's because of line 3 that you have done the change over there. Okay. We okay? All right. So now I think you're almost ready to write complete post condition. Almost. So far we haven't talked about. So far you can think about this way. The old imp we have we have over here, we have to manually copy that by saying either old imp is assigned to imp or old imp is assigned to imp.twin or deep twin, right? We're going to manually do it. So now we want to learn about how do we trigger for runtime to do things like line number 1 for us automatically. That's the thing we want to think about. Okay? If you do Java, of course, you have to manually encode the pre-states. But in IFO, you don't have to, as long as you know how to use the old keyword. Okay? I'll just start with that, and then just give me 10 minutes, and then we'll see how much we can achieve. Okay, let me go all the way to the end of this particular example here. I will also make the source code available for you, so you can also look at them. Okay. Okay, let's talk about how do we check contract at runtime. Okay. This particular slide, let me take a look. Oh, we're getting there. Okay, basically, good. Okay, so let me just use iPad to show you quickly. Okay. Let's say this. Let's say this is a contract view for your class or a particular feature. You have require, okay, there's some Boolean condition. Also, you got to ensure. And the ensure might have to use the old keyword. Okay, remember old is actually a keyword in IFO, which means if you use it, you have to know what the consequence is at runtime. Okay, the consequence is really important to understand. Let me just tell you roughly the timeline, how things are going to happen, and then we talk about examples. Okay. So now let's say if I try to call this particular feature f. Okay. First of all, we're simply just going to check the precondition for f, right? It's kind of related to our state diagram before, so that's consistent. Okay. So now here's something new. Once we know the precondition of f is actually satisfied, so now we're in this particular state. I call that a pre-state. Okay, so now here's the thing. Eventually, the post condition, let me go a little bit further. Eventually, we have to somehow check the post condition of f, eventually. And the post condition of f might contain like an O expression, like using the O keyword. Okay? In that case, I call this state upon which we check the post condition, the post states. So here's the thing. As soon as the implementation of your feature is executed, no pre-states will be available. They'll be wiped out. Basically, they'll be overwritten. So that means when you are right before you try to make the changes by the implementation body of your feature, you have to somehow store the pre-state value that might be necessary later. Okay? What do I mean? I'll give you one example. Let's say if in my ensure clause over here, if I got, for example, old balance, okay? If I just say that, so that one is basically telling the runtime telling the runtime execution machine, when you are in this particular pre-states, pause over there, don't execute the body of the implementation just yet. Look at every O expression in the post condition to see what should be stored right now so that we can compare later. In this case, we have to somehow store the balance. In that case, so that means you got to cache the O expressions, make sure to store them aside. And this process is entirely automatic. You don't need to do any caching yourself, but you have to understand how it is done. Okay? Okay, after this, we have to execute. Okay, as soon as you execute the body of the implementation for f, so now pre-state is basically gone. So now, when you are at this particular point, which is in the post states, if I say something like balance, for example, equals old balance, let's say old balance, for example, plus 100, for example. Okay, so now balance is very easy to get access to because it's simply the current value in the post states, right? You can think about this balance over here is the post states. What about the old balance over here? It's supposed to mean the balance value in the pre-states, but the pre-state is already gone. How can we get access to it? We have to refer to whatever O expressions we have cached or stored previously. That's kind of the entire process. So you have to be very careful about how exactly you write your O keyword. Okay? Given that we only got about 6 minutes, I wouldn't go into details. I want to show you the possibility of the O expression you can write. And then we'll talk about the difference next time. Okay, let's take a quick look. We got pre-states and then we got post-states. Okay, here's the principle. Okay, easy. Let me write down the principle first. If you have if this is your feature over here, right? let's say this is the only O expression in your post condition. Okay, how do we cache the value? Okay, so now immediately before the do. Okay, so before executing the implementation, the caching process is the same for every old expression. You will simply do the following. What IFO will do, they're going to create some temporary variable for the old expression. For example, they might simply call it old underscore expression. Okay, whatever name it is. The name is not important, just some variable there. And then they will always use this particular assignment operator. And then whatever expression that goes after the old, they will simply be copied verbatim. So this is going to be done automatically for you for every old expression. So what does that mean? That means, would it make a difference? Expression might be, for example, A, let's say A is an array. It could be A dot twin. It could be A dot deep twin. Can anybody try to take a guess? If I write in my post condition over here, I say A versus A dot twin versus A dot deep twin. Is it going to make a difference when I do the comparison? Try to see if you can draw the connection to the old imp and imp we just did a few minutes ago. That's exactly why I want to do that example first. Okay, let me recap quickly. Okay, the way you write your old expression in the post condition is very crucial. If you simply say old and then expression, the caching process for IFO at the runtime is just the same. Okay, it will be as easy as just create some temporary variable automatically, just assign to whatever the expression is verbatim. So now, this expression is completely up to you as a programmer, completely up to you. So now, if you put A, that means only A is going to be copied over to old expression, a reference copy. If you actually wrote old A twin, that means you're going to get A dot twin over here. That means a shallow copy of the pre-states for A is cached. On the other hand, if you say old A dot deep twin, so that means over here you're going to cache a deep copy of the pre-state value of A. Right? Conceptually, is that okay? Okay, let me take 1 more minute from you over here. So what are the possibilities? I would say before Wednesday, try to think about what the difference might be. Example could be, you might say, let's say this. If we have, let's say, a bank account, like a bank class, and then accounts is simply an array of accounts. So you might say old accounts at position I.id. For every account, you can get its ID. ID, let's say, is simply just integer. I might write old accounts I.id. I might write parentheses old accounts I, then .id. I might write things like old accounts I .twin parenthesized .id, things like that. I got so many possibilities. And notice that these are not exhaustive. Okay, this is kind of the intuition and understanding I want you to get, hopefully by the end of Wednesday. Right? This is really important for you to write complete post condition. Okay, we'll finish earlier today. I'll see you on Wednesday.